So if you run down an escalator the right way, you travel with the sum of your speed and the speed of the escalator. But if you run up the escalator, you're running against the speed of the escalator. So you're going to have to take away the speed of the escalator from your speed to get your overall speed. And something similar happens in these following examples. So let's have a look at the first one here, and we'll work our way around starting with A, and we'll look at the forces on all of the individual particles involved in these questions. So we can see, I'll do a blue for the blue string, and then we will go red for the second string. So we have two strings, so we go T2, we go T1. Going to identify them, the directions of acceleration, really important. We have 5m. Now because these are m and 5m, we could change to 5, 1 and 1, but I'll leave it at 5m and just like they wanted in the question. So going down we have 5mg. So this is A. We have the first string going up. We'll call that T1. We'll call it T1 and T2. I think I called it T and T1 before. We'll call it T1 and T2. And then the 5 is obviously going to come down. It's much heavier than the two ones. So the acceleration is going to come down in this direction. So my equation for this is 5mg minus T1 is equal to ma 5ma. So they tell us it moves over. So we're at B, we're at A, and we're moving to C, and it tells us about C, a light movable pulley. So the mass is technically 0 if such a thing can exist. So we look at C next. So C has a string going up, which is our T1, and it has two strings coming down, which we have called T2. And if 5 is going down, C is going up, and it's connected by this string here. Well, let's have a look. We know A is going up in this case. So we'll start with that. We'll say T1 minus twice T2 is equal to m. Well, they said negligible. This negligible m gives us a mass of 0. So 0 times A is for C. And then if we look at D next, D in red. So D has mass m, so we have mg. The string attached to D is T2. Over here, T2. And the acceleration of D, well, C is going up, so D is going up. So it moves up relative to C with acceleration A. And I'm just looking here, this M here in the question is actually a mistake, which you guys that have the book will see. This is 3m in the question itself. So that's why D moves up with acceleration A, because C is moving up with A, and it also moves, well, this guy E is coming down with different acceleration, we will always call B. So this guy is moving up with B as well. So the acceleration of D is upwards with A and B. So my equation for D, starting with T2, it's moving upwards, T2 minus mg is equal to m, which is just m, times my acceleration, which is my A plus B. And if we go on to E is going up with acceleration A. So I've got E. I've got T2 attached. I've got my acceleration. I'm going up with A, down with B, and I've got my 3mg. So it's going down and up. That's possible. It is possible. So E is going down relative to C. So we're going to have 3mg minus T2 is equal to m, which is 3m times my acceleration is going to be, well, it's going down with acceleration b, and the acceleration that's opposing it up and down that escalator is A. So if I multiply these out, T2 minus mg is equal to ma plus mb if I need to. 3mg minus T2 is equal to 3mb minus 3ma. So let's bring these four equations together. What have we got? I can write the second one as T1 is equal to 2T2. That might simplify things down for us a little bit. Well, let's have a look. I'll write all the equations up here. I've got T1 minus 2T2 is equal to 0. I've got T2 minus mg is equal to ma plus mb. And I have 3mg minus T2. 3mg minus T2 is equal to 3mb minus 3ma. 3mb minus 3ma. So we want to solve for a and b. I can see these two equations, if I combine them, I'm going to get 3mg minus mg, which is 2mg, is equal to 3mb plus mb, 4mb, and I'm going to get minus 2ma, and I can cancel my m's here. 2g is equal to 4b minus 2a, and I can divide by 2 to get g is equal to 2b minus a. So I just need to look at another few equations. I've used these two, so I need to now expand my horizons to these two, and I can get T1 is equal to 2T2. So if I can put T2 in here, if I can put this as 2T2, that will enable me to use one of the first two equations I've used already. So I need an equation with plus 2T2. So if I multiply this one by 2, I'm going to get plus 2T2 minus 2mg is equal to 2T2 minus 2mg, 2ma plus 2mb. Sorry, that's 2 plus 2. Let me just write that guy out, 2mb. And combining these two equations, I'm going to get 3mg is equal to 7ma plus 2mb. So divide by m. So I now have 3g is equal to 7a plus 2b. If I multiply this one by 7, I'm going to get 7g is equal to 14b minus 7a. So 16b is equal to 10g. So b is equal to 10g over 16, 5g over 8 meters per second squared. And if I have an equation, can I get a from this one? A is equal to 2b minus g. A is equal to 2b minus g. A is equal to 2 times 5g over 8 minus a full g, so I have 10g over 8. A is equal to 10g over 8 minus 8g over 8. So A is equal to 2g over 8, or g over 4 meters per second squared, if you want to write it like that.